Welcome to all of you. My name is Aman Gupta and I am a student of MCA first semester at Vishwakarma University, Pune. Today I will discuss steps of problem analysis in DSA. Steps of problem analysis. Almost every day you will come face to face with a problem. Some problems can be solved quickly, but others may take more time, thought, and efforts. There are many different ways to solve a problem, but it is important to use the most suitable method for each specific task. First one, problem identifications. Second, algorithm. Third, flowchart. Fourth, program code. Fifth, compilation and execution. Sixth, debugging and testing. Seven, documentations. Now we are going to talk about in the details. First, problem identifications. Identify the core problem by gathering and analyzing requirements. Understand the end goal and any constraint that might impact the solutions. Define inputs, outputs, and the expected behavior of the solutions. In these steps, we gather requirements, understand constraints, and define the scope of the problem. These help prevent misunderstandings and ensure everyone involved has a clear goal. And problem identification is the foundation of the entire development process. Example, if the task is to develop a calculator, specify the types of calculations needed like addition, subtraction, multiplication, divisions. Second one, developing an algorithm. An algorithm is a step-by-step sequence of operations needed to solve a problem. Think through the solution logically and ensure it's efficient and covers edge cases. An algorithm is a sequence steps that outline the process for solving a problem logically and efficiently. It's like a blueprint that helps developers think through the solution before coding. Example, for a calculator, an algorithm might include steps like input first number, select operation, input second number, calculate result, and display result. Third, creating a flowchart. Flowcharts visually map out the steps in the algorithm, making it easier to spot issue and understand the flow. Use standard symbols. Example, ovals for start and ends, rectangle for process, and diamond for decisions. A flowchart is a visual representation of the algorithm. It helps in visualizing the flow of control through the steps and make it easier to spot logical issues before coding. Example, display a flowchart for a basic calculator that includes input, operation selections, calculations, and output. Start with the oval for start. So input, process, and output with rectangles. Use a diamond for the operation selections, branching into path for each operations. Fourth, writing program code. Convert the flowchart and algorithm into code using a suitable programming language. Ensure code readability and maintainability with meaningful variable names and comments. Programming is the process of turning the algorithm and flowchart into executable code. This step involves translating each part of the plan into a specific programming language. Example, define the two integer number int a, enter the first number, b input, enter the second number, calculate their sum, result equal to a plus b, print the result, print the sum of a and b is result. Fifth, compilation and execution. Compilation translates the code into a machine-readable format, and execution runs the program to see if it performs as expected. Compilation converts source code into machine language so it is be executed. Execution then runs the program to check if work as expected. 6. Debugging and testing. Debugging involves identifying and fixing bugs in the code, while testing verifies that the programs work as intended under different conditions. Debugging and testing are critical for identifying and the correcting errors. Testing validates the program works under the various conditions, while debugging isolates and resolve specific issues, like demonstrate a common bug, division by zero in a calculator and show how it's undefined and corrected. Example, calculator test cases might including adding, subtracting, dividing by zero and handling non-numeric inputs. Seventh and last steps, documentation. Documentation helps future developers and users understand the program purpose, functionality and uses. Documentation helps others understand the maintain the code. It includes comments, a user manual and any maintenance instructions. Conclusion. Effective problem and analysis is critical to designing efficient algorithm in data structure and algorithm. By systematically following the step, understanding the problem, identify inputs and outputs, considering constraints, choosing appropriate data structure and analyzing time and space complexity, you build a solid foundation for solving the problem. Test and optimizing ensure correctness and efficiency, which are vital for tackling real-world challenges. Following the structured approaches help to break down complex problems into manageable parts, leading to more effective and optimized solutions in DSA. So this was all about the steps of problem analysis in DSA. I hope you like the presentation. Thank you.